Hello, welcome to lesson 14-2 on linear equations, y equals mx. Hopefully the sound quality is a little better today than it was yesterday, trying out a new system. So before we get started on the notes again, we just want to remind ourselves we are going to need the notes for 14-2. Make sure you pick them up on the black box on the side of the room. And we'll also need your vocabulary sheet because we're going to start filling in some of our vocabulary words. So just to recall from the fall and from yesterday, a graph shows a proportional relationship if it is a straight line that passes through the origin. Example number 1 states that the graph shows the distance d a car travels in time t at a constant speed r. We have 4 questions that we need to answer based on the graph. So looking at the graph, the first question says, what is the constant speed of the car? So what I need to do is look on the x-axis where my quantity in time is going to be 1 hour. And where that is 1 hour, I match that up with the y value on the y-axis, and I see that it is 30. So that means I would go 30 miles in 1 hour. So 30 miles per hour. Question B says how far will the car travel in 2 hours? So I will do the same thing that I just did to find the constant speed. I look at 2 on my x-axis for 2 hours, draw a line up to the line that has been plotted, and go over to the y-axis, and I see that 60 miles corresponds to how far the car will travel in 2 hours. C then says how long it will take the car to travel 120 miles. So this time I'm looking at my y-axis at 120 miles, draw my line over, see where it meets the line that's drawn, go down to the corresponding x value, and I will get 4 hours. For part D, it says write an equation in d equals RT form to model this situation. Remember, D stands for distance, R stands for the rate, T stands for the time. So if I know that the rate is 30 miles an hour from part A, I can just substitute in here D and then substitute 30 in place of the R and have the time there. Now we'll go on to example number 2. This one says the graph shows the distance d a train travels in time t at a constant speed r. Write an equation in d equals RT form that models the situation shown. Go ahead, pause the video, and figure out what the equation is. Okay, hopefully you had enough time there. The answer is d equals 100t. Looking at my graph, I lined up when the time was 1 hour to 100. This is where on you're going to need your vocabulary sheet, so go ahead, take a moment to fill this in. On your notes, it has the key concept, which talks about the same exact thing that we're going to put into your vocabulary right now. So go ahead, pause the video, and fill that definition in. Next, example number 3 says a restaurant is running a lunch special. Write an equation that models the lunch price y based on the original price x. So we just learned in the previous slide that a linear equation, linear having the word line in it, is an equation in the form of y equals mx. The graph of all its solutions is a line. So the m, as we talked about yesterday, is our constant of proportionality. So we come back over here, and if they say lunch special, all prices are 1/3 off. Going back to our percents unit, if the original amount is 100% or 1, and it's 1/3 off, this is the amount that it's going to be off, is 1/3. Well, 1 minus 1/3 will give me 2/3, which is the price that I'm actually going to pay. I'm going to pay 2/3 of the original price. So using y equals mx, My constant proportionality that I will always pay is the 2/3 the price, so I will substitute 2/3 in place of the m and get y equals 2/3 x. Pause the video. Hopefully we had enough time for number 4. Same thing, very similar to what we just did in number 3. Again, we've got a hamburger patty. Now we'll be thinking about some lunch here. Hamburger patty that is 1 pound. It loses 1/4 of its weight. So 1 minus 1/4 will give us 3/4 to how much the hamburger will actually weigh. So we have y equals 3/4 x. Let's see, next. Example number 5 says the number of words you can type in x minutes can be represented by the equation y equals 55x. The number of words your friend can type in x minutes is modeled by the graph. Which of you can type faster? Well, from the equation, they're saying in y equals 55x, that represents you. You can type y equals 55x, meaning m was your constant of proportionality, so that means that you can type 55 words per minute. I'm going to use WPM for words per minute. If I look at the graph, if you notice on the x-axis, they don't have time in 1 minute anywhere, so I'm going to have to come up with my own constant of proportionality. So I'm just going to start with the 3, draw up to the line, and go over to the corresponding y value. And for my friend, I could figure out how many minutes it takes. Well, if it's 150 words in 3 minutes, I can reduce this and divide it down to 150 words per minute to now become 50 words per minute. So the question's asking, who can type faster? Well, if I can type 55 words per minute, I can type more words per minute, so you can, not the friend. Go ahead to number 6. Try that one out. Pause the video. And then we're back. So it's asking for the number of miles the Y car travels in X hours. They're giving us the equation y equals 65x, but they're asking us to then compare that to the graph. So in the graph, they did give us 1 hour, so we have 75 miles per hour, which could also be written as miles per hour, either way that you would like. And so which vehicle is traveling at the greater speed? Obviously, the train at 75 miles per hour. Thanks for watching. We'll see you tomorrow.